Hello everyone, I'm Christopher, and in this video we're going to break down game architecture. This video is for all game developers, both big and small. No matter what game engine you use, there should be some key takeaway points that you can use to improve your project. You also don't have to be any form of super technical person here. These are organizational and production breakdowns for game development. You can be a designer, artist, writer, or programmer. All disciplines can have something to learn on how to think about structuring your game. We really wanted to show how they will be key to game innovation, lowering costs, and speeding up development. This is the first video in a series, as there's just too much to cover. This is a major video we want to have on our channel that can be easily shared to other people, and for our own point of reference of VerticalThird is trying to achieve. The video is separated into chapters, so feel free to jump around to specific topics. For a quick recap on who we are, we've been using Unreal Engine for 10 years. We've received $100,000 in funding through 2 Epic Mega Grants from Epic Games for VerticalThird, our game architecture for Unreal Engine 5, which we're continuing to update and improve. We are Unreal authorized instructors, and we're hired by Epic Games to create the UEFN course for the Unreal Editor 3D modeling tools. And we're authors on a major education project, the Epic Games Game Design Professional Certificate on Coursera. We handled courses 5 through 8, where you learn how to prototype 6 different game modes: action combat, story, crafting, capture the flag, platformer, and stealth survival. We have been on the Unreal Engine livestream 3 times for VerticalThird, building and sustaining communities, and Ruins of Tearyn. Ruins of Tearyn is our indie MMO that is powered by VerticalThird, and we have a separate video on how we are strategically approaching that ambitious project. And hey, we do playtest quarterly, so join our Discord to find out when the next one is. For examples throughout this video, we'll be using both VerticalThird, Unreal Engine, and Ruins of Tearyn. But as mentioned earlier, these are just organizational concepts that you can implement into your own game project. We wanted to create a video that deep dives game architecture and start more discussions with the game development community around the topic. Let's start by defining what a game architecture is so we're all on the same page. A game architecture consists of your project's organization, communication, and usability. How you lay out your folders, systems, code, and art. Your naming schemes for each file you create. How each system communicates with each other, such as acknowledging the quest system when a quest item is looted. How easy it is to add content to your game. Here's some of the results when you have a good game architecture. You can search for game assets easily. Systems are very modular in design. The game is easier to optimize. Clean code practices are enforced. Game designers can add content efficiently without headaches. And programmers can have a clear vision on how to add new features without disrupting other systems. With that out of the way, remember to like and subscribe. One of the biggest problems you have in game development is time and money. For most game projects, you have a budget and a timeline when that game needs to either ship to players or hit a major milestone for more money. And in most cases, there is not enough time to build and architect game projects properly and efficiently. Nor can you predict how the project will grow and change over time. Pivoting in game direction is very common, and that has the potential to jumble up your project's organization. This leads to tech debt, bugs, edge cases, and hard-to-use systems. And tech debt is when your early choices of technology end up slowing you down in later stages of development. In many cases, it would take too much time to go backwards and fix the tech debt problems, so developers are stuck working inefficiently. And the main cost in game development, whether you're working for yourself or a company, is employee salaries. So as the saying goes, time is money. All this leads to having to ship games with duct tape all over your game, spaghetti code, and bugs you can't fix in time for release. So the solution to all of those problems is having a robust game architecture. This is where they're going to come into play. Well thought out, optimized systems that are easy to use and modify. Every game is going to have very specific niche adjustments to them, so adaptability and being flexible is very important. Systems that we can consistently improve over time instead of throwing them away after each game that gets made. You can imagine how much time is spent on rebuilding combat systems or quest systems that often from the player's perspective all feel very much the same. You don't need to innovate on a collect quest or a kill quest. Those are pretty standard throughout all games. So why are we having developers rebuild those same systems over and over and over? It would be much better if they can focus on the next big innovation gameplay thing that changes or builds upon those systems. In the 2010s, we got game engines such as Unreal, Unity, Godot, and GameMaker. This is all a logical step in game development, as prior to this, you would have to spend years building your own game engine. This is before you even start making your own game. On top of this, you would need game engine programmers to upkeep or improve your game engine technology over time. So now, our thesis is that game architectures will be the next big leap in production workflows. And this is why we are creating this video, to try and push more discussion around the topic of game architectures. As mentioned before, throughout this video we'll be using examples from VerticalThird, our own game architecture, which is available to start on Fab for $20. And a key point we like to make here is that you can use VerticalThird in several different ways. And this will also be the case for multiple game architectures in the future. The first obvious reason is to power your next game with complete systems. That those systems have gotten feedback from other game developers, and they are optimized and will take years of development off your scope and let you focus on more innovative designs. In general, it will let you build your game faster and under budget. The second is as a designer sketch tool, and maybe you're already deep in development and you can't make the switch to VerticalThird. Designers can implement their ideas quickly to test early designs before implementing them fully in your main project. Our personal goal is to make it as easy as possible to transfer from a paper sketch to an in-game test. The third is for education and as a resource. There are many example game architectures out there, so being able to deep dive how one is organized can be very helpful. There should be also quite a bit of well-documented code to help you understand how game mechanics are implemented. And finally, for prototyping. Maybe you won't use a game architecture for your core development, but during pre-production, you can get quick ideas and gameplay down with fast prototyping. A lot of times when you're running a company as a business, you might launch your first or second game, and you will have a small window to figure out what you're going to build next. This is the type of period where saving time is so essential to prove out different game concepts. Many game companies will run internal game jams that will lead to what game they are pitching to the next publisher. And would you believe it that in many game production cycles, game designers don't get proper tooling to implement content until late stages of development? This is a byproduct of core systems not being complete. If your quest or combat system isn't done yet, you can't really make proper designer tools that are going to function correctly. This leads to one of the major problems games have today, content production. Empowering your designers to create content for players should be a top priority for keeping up with the demand. This is why we're pointing out that game architectures should have proper designer tools that are easy to use. Using VerticalThird as an example, we use Unreal Engine's data tables for designer tooling. This lets designers create combat abilities, quests, equipment, loot, crafting recipes, all through simple number changes, checkboxes, and drop-down menus. In our blueprint code, these all break out into structs, so the data for our game is separate from the system. And this is where we feel the current tech stack of a game is broken down to: your game engine of choice, your game architecture, your designer tools, and then your game's content. And in today's modern day, you will likely have some sort of backend or cloud functionality for backups, achievements, matchmaking, or dedicated servers. Some examples of this would be PlayFab, GameLift, or Epic Online Services. But you can see there are potential years of time saved from having a solid pre-built foundation for your game. And for game architectures in their current state, many developers will have a mixture of different marketplace products, middleware, and building their own systems. Before we get started, a small disclaimer here is that treat these as guidelines for your project. These are in no way rules that you have to follow. They're just lessons learned from our experience working on our game architecture, VerticalThird. The purpose here is to give you a direction on where to go and how to properly structure a game project. This is obviously very biased towards Unreal Engine, so some of these features might differ depending on what engine you're using. And lastly, I can't emphasize this enough, I want to create more discussions around this with the game development community. So please leave comments on this video, or to have more in-depth conversations, please join our VerticalThird Discord server. And with all that out of the way, let's get into it. We're going to start off with something simple and obvious, that are naming and folder conventions. something that sounds easy but gets more complicated with time. The first part about usability within a game engine is search functionality. Instead of digging through massive folders or trying to remember where something is, you should be able to search for what you want to use. Game engines by default will have specific filters you can use to narrow your search, and advanced search syntax to even further identify what you want to find. Your project will get convoluted with marketplace products as well. They'll all have their own naming schemes. Unreal Engine also includes the folder path in the search filter, so it's possible to include search terms in the folder itself, which can make your file name smaller. You could have a folder named characters, and then all assets in that folder no longer need to have the word character in it. The other part is how folders sort their files, typically by alphabetical order. Because of this, it's worthwhile to do reverse naming conventions. Instead of naming it blue enemy character, we would name it character enemy blue, which results in all character enemies grouped together in the alphabetical list. I should also note that you should always aim to have each file have a unique name. Shit happens in game development, to put it bluntly, and you don't want a random folder or file move to overwrite other files. If you have a death animation for Manny, it should still be named Manny_death, instead of a folder called Manny_animations with a death animation file. This would avoid potential problems in the future if for some reason a different character death animation got moved to that folder, overriding it and causing a bunch of problems. It's much easier to fix a folder move than it is to figure out what is going on with a broken animation file. And then onto folders, we aim to have very shallow folders when possible. I'd rather have a specific folder higher up in the chain because it leads to less clicks if you're browsing by mouse. My example here is through our user interface folders for widgets. Everything is clearly marked and segmented into their modular components. Using reverse naming, I know all my widgets can be found at the bottom of the VerticalThird folder. Inside each folder are the few files that each widget will use. Going back to my note about marketplace content, we like to create a MP folder and take the time to move all marketplace assets to this folder. Unreal specifically can be very slow at this, even more so when you have source control like Perforce installed. The reason for this is that Unreal has to update all references when you do a folder move, and that can take a lot of time for each file involved. If you just want to explore and try to drag those marketplace assets to the MP folder, all your references would break and things wouldn't have the proper texture set. So it can make a lot of things go wrong. So you have to do this in the engine itself, moving folders. Again, if you have source control, this can take ages for some reason. But it does lead to a much more organized product. Marketplace content adds up very, very quickly. A lot of times as developers, we're throwing everything in the kitchen sink into the project, so we want to be able to have a way to organize all that chaos. Along the lines of file naming, you should have variables and function names. Be very specific and clear with your names for these. You don't have to worry about how long these get, and it will lead to more readable code from your team or in many cases, yourself if you're a solo developer. Context switching is very much a thing. We go back to fix bugs or update a system you haven't touched in several months. It helps when everything is labeled correctly. I use the reverse naming scheme here as well, so variables and functions are grouped together alphabetically. As you can see, Unreal Engine has the ability to add categories to variables and functions as well. This further helps you keep things tidy and easy to find. Not only is it good practice to comment your code once it is in a relatively complete state, you can also add tooltips, descriptions, and search key terms. VerticalThird is a data table-based system, which is Unreal Engine's file type for spreadsheets. I've separated my content and code for all my combat abilities, loot, quests, and more are all stored in data tables. So I keep all files related to content in the database folder. This keeps all of the game design content for Ruins of Tearyn in a single folder, separated from all the VerticalThird system code. Lastly on this topic, instead of even having to search for an asset, consider making a quick tool to automatically use them. For Ruins of Tearyn, we are using the Scriptable Tools feature in Unreal Engine 5.5 that lets you create multiple buttons for our crafting gatherables. Instead of having to search for a loot spawner, dragging it out into the world and setting its data, I can click a button with predefined data It automatically searches for collision with the environment and can use the mouse wheel to adjust its size and rotation. One more click and it's planted and ready to go. This is a simple example, but think about removing the need to search for an asset and replace it with a button to improve your workflow. And this leads us into one of the major game project files, the player character. The player character will quickly become one of the most bloated assets in your game. This personally happened to us during our time working on a past project called Castle Day. The more features we added, the best place to put them was usually on the player controller or the player character, which led to why we ended up breaking up the character's code into different actor components. This further leads to modular design and coding principles like solid, in this particular case, single responsibility systems. And so far, here is our breakdown. First up, we have the input component. This component handles what happens when the player pushes a button, initiating combat abilities or interacting with objects. For VerticalThird, this component checks action data for requirements such as range or line of sight, requiring a target. If the ability is on a cooldown, does the ability have positional restraints like a backstab, or if the ability needs to have the button held down. It will either fail and prompt an error to the player, or finish and initiate the cast to the game architecture's action system. Another important takeaway for this component is to have a very robust casting system that all systems can utilize. So you can initiate a cast when you are creating an item through the crafting system. That way, if something interrupted you, or maybe you are crowd controlled, you wouldn't be able to craft that item because you're using the same cast system from the input component, just like the combat system. It would also use the same system for showing your cast bar from a user interface perspective. And it would be the same for initiating an animation when you're trying to craft that item. As you can imagine, the statistics component is pretty self-explanatory and handles all stats for the character. Your health, your mana, your crit chance, your parry, dodge, armor, resistances, you name it. It will also manage your core damage and healing calculations, while also managing buff, debuff, and crowd control timers. We'll talk a little bit more about this when we get to the action system. Crafting, inventory, and quest components are all straightforward and handle all code related to their specific systems. The targeting component manages the player's target and controls the ground targeting system. This is where you store your data in the case for tab target MMOs. This can sometimes also correlate to auto-targeting on what is in front of you. And as mentioned, it can be used to target the ground for area effect abilities. The experience component handles how that character gains or gives experience. It also holds all code related to when a character levels up and what happens in that event. The death component handles events that should happen when this character dies. This can be changed depending on if it's an AI or a player. The action manager is something that holds all loaded abilities for that character. For VerticalThird, we've separated our action manager into 3 parts. The master blueprint holds all code related to passive actions such as on hit or on crit effects. These can be loaded through abilities or equipment. From there, we fork the action manager into 2 child components, the player action manager and the AI enemy action manager. This lets you set up different loading schemes for the player compared to your AI enemies. The action manager will also track cooldowns for all abilities. This includes internal cooldowns for passive abilities. The widget component is effectively a manager for on-character widgets, such as nameplates or scrolling combat text. The MeshVFX component is for, as you can expect, visual effects for your mesh. A simple example of this would be fading the enemy in when it spawns, or fading it out when it dies. Some of these effects can get complicated, and depending on your game, there can be a lot of these to implement. VerticalThird systems are pretty basic here, but you can imagine this can get very, very complex. And this is a component that can also manage your cosmetics for each character. The team component is for all party or group type systems. This can manage the invite and accept kind of portion for the group, and tracks the data for all associated players in that group. An animation component for all animation-related code. This can very effectively help manage the animation state for your characters. You definitely want to have a robust way of activating animations through a core system, instead of all over the place through your code. In game engines, you can have multiple animations playing at the same time, but the animation with the highest priority is the one that will be seen. So by making sure you have a proper flow on how animations are activated, can drastically reduce potential problems and help troubleshoot them in the future. The GraphData Component is something that you might not think about, but any type of data you want to track can go here. You can imagine in many multiplayer games, there's a lot of potential here, especially for match-based games that are tracking player statistics through each session, such as wins, losses, and playtime, or maybe champion performance throughout the match. But for VerticalThird, we are doing something much more basic, like tracking damage and healing done. And for AI enemies, this is also where we track how much threat each player has. The loot component stores all information for loot that this character will drop. In VerticalThird, we use a simple slot-based system here. You can have multiple slots. Each loot slot has a list of items from a drop table. And in an example, if you have 10 items in a list, each item has a 10% chance to drop. You can add the same item multiple times to the list to increase its chance to drop for that slot. In addition, we make sure to use a soft reference data table for this. This is so the loot will only be loaded when the character dies. And once the character dies, it will trigger the character loot spawning system. We'll also come back to that a little bit later. The progression component handles systems like talent trees or skill graphs. We all know that these systems can range from a few simple choices to incredibly complex graphs with millions of different potential options. So it's really good to have a direct component that can manage all of those choices. When it comes to AI enemies, we have 4 additional components. The logic component is the effective brain of the AI, collecting all the data the AI needs to make a decision. The combat component is the AI version of the input component. It will manage the casting and ability rotation for the AI enemy. The movement component is pretty straightforward and handles how the AI moves, including if it's patrolling around the world. And lastly, the threat component, which, as you can imagine, monitors the threat meter and changes the target should someone get higher on the list. In the future, we'll break down these buckets of code in more detail, but again, we're trying to keep this one as a bit of a small overview. Moving on to the player controller, you have quite a few custom integrations here that are very specific to your game. For VerticalThird, we make sure the game menu is always accessible from the player controller and is not attached to the character-specific HUD or user interface. This makes sure if the controlled character has been destroyed in any way, the player always has access to the game menu. Also placed to control chat systems for multiplayer and client-side camera controls such as hiding nameplates, your own character, or hiding all user interface elements, the stuff that makes making screenshots easy to do. Specific to Unreal Engine and multiplayer, the player controller is never replicated to other clients, so you have a specific place for code to communicate to a dedicated server regarding player account details or purchase requests when interacting with the storefront. Your user interface should have a root widget that holds all modular components. In Unreal Engine, there's a HUD blueprint that is where you initiate and manage all communication with the user interface. For VerticalThird, we are careful with hard referencing widgets throughout the project, so we do that through the HUD, where we originally referenced the creation of the root widget. And from here, we communicate with the HUD through object-based interfaces throughout other components. And on that note, while this might be Unreal specific, I believe interfaces are the best way to communicate through your game project. The character, controller, and HUD are all easily accessible through Unreal Engine. VerticalThird interfaces typically always use an object-based reference, which is the most basic class you can reference in Unreal Engine. While they also enforce coding standards, making sure all code specific to a component stays within that component. From there, you can access the component's code through an interface function. And if a rework is ever needed, you know exactly where that code is and which function to modify. In many cases, the output of that function might not change, but the internal code or algorithm to calculate the output might be different. When working internally with a component, functions should be used as much as possible. This makes your code reusable, modularized, and fast. The Unreal Engine functions are intended to be completed within a single frame. Keeping your functions small and with a specific purpose is key to creating clean functions. I mentioned this earlier, but your systems should be built in a way that your code is separate from your game data. So you have a combat system, designers will have a data file with so-called instructions on what the single ability will do. In the case of VerticalThird, we have our components are the code for each system, but in our database folder, we have the so-called fireball ability with all the details on what the ability does. This lets designers have an easier tooling system that they don't have to get in and do any coding themselves. On the topic of localization, this is something that comes up often in indie game development. You want to avoid hard coding strings for user interface or other player-facing text. Unreal Engine has a very robust built-in system for this, and with VerticalThird we have two localization files, one for single words and one for phrases. I have on screen here some of the standard text that you expect for something like this. When you go to add text to a widget, you have the option to add a string from a localization file. This is the proper way to prepare a project for the future when translating to other languages. And on the next up, we have spawners. The first one will be an AI spawner. One core of the AI spawner is to be a placeholder object to help with editor performance. This means you don't have to load in a full character model and the associated character data while working in the editor. It will also manage the respawn cycle when an enemy dies, the patrol pathing, and a myriad of other possible spawn settings. You want the AI spawner to be separate from the AI, so when the AI character is destroyed, a separate entity can manage its respawn cycle. In addition to the AI spawner, you can have a spawn manager. This will activate and deactivate spawners in a large area if no players are nearby. When a player leaves the area, it will either destroy the spawned AI or put them in a stasis mode, which limits their AI capabilities to save on performance. And similarly, there is a loot spawner for the world. This can be for quest items, collectibles, and crafting materials. And a loot spawner for characters, which handles the loot table and drop chances for that character. Just like the AI spawner, having a separate character loot spawner allows a different entity to manage the process, so when the character is destroyed, the loot spawner is not affected by it. On this note, your loot system should be very data-oriented, just like the previously mentioned example with the fireball. In VerticalThird, we have a simple loot actor. When it is spawned in the world, it is assigned the appropriate data table from the database, and when a character picks up the item, that data table struct is added to the player's inventory. The loot data table has a whole mixture of loot settings, from its appearance, stats it gives, equipment, or quest item, tons of stuff. Finally, one of the biggest spawners of all, your action spawner. For VerticalThird, our action spawner is effectively our ability system. And I want to clarify the way of thinking when it comes to creating a combat system. I've already mentioned a few components that help modularize your combat system in your game architecture. First, there was the input component that handles what happens when a player presses a button, the targeting component that tracks players' targeting, and the statistic component that manages and calculates all player statistic changes. And what that effectively leaves us with, the core ability system, is hit detection. For VerticalThird, we've broken hit detection down to a few different methods. You have a standard area effect, which is a shape-based hit detection. You have a volume area effect, which is an attached collision volume. This can be used for an AoE that grows over time, or for a charge ability that helps extend the hitbox of the character. Then there is the pulse area effect, which is your typical fire on the ground hit collision. From there, you have the projectile, which is just a moving object with a collision volume attached. A projectile can have a few different forms, such as bouncing, homing like a fighter jet missile, or always hit like a tab target MMO. Then you have beams, which are multiple straight line hit collisions. This can be beams that come out of the character's hand, or placed on the ground that can have many different rotation options. There is cone, which is a series of straight line based collisions that pivot at an angle. With timing options, you can use short cone effects as an alternate way to execute melee action combat. Then you have direct target, which requires no collision, self for actions that you want to target your own character, character collision for charge abilities that react when the character collides with an object, and for guns you also have a hit trace, effectively an instant line trace wherever the player is aiming. Now, on our to-do list for VerticalThird is a more advanced form of melee collision, where you have a volume around a weapon that gets enabled at the start of attack and disabled at the end of attack. If anything is detected in between those periods of time, they will trigger a hit. And while a bit separate for hit detection, you also have actor spawns for spawning pets or other enemies, and then you have mobility actions for teleports, dashes, sprints, and dodges. When a hit is detected, it will use the action data table to pass on the statistic changes to the statistics component system. As an example for all this, after a player presses a button, the input component will spawn the action spawner with instructions on what type of hit detection to use. When a character is hit, the action spawner will pass on the statistic change instructions to that character's statistic component. This creates very isolated responsibilities for each step of using the ability. This next topic is a little bit of performance and optimization. Spawning and destroying anything in a game world can take a toll on performance at high volumes. When you're spawning and destroying a large amount of different objects in a game, it can quickly add up in terms of performance. Most games will have potentially hundreds of abilities spawning at a time, especially in multiplayer games. So it's important to have pooling or other features to reduce this cost. Pooling is when you spawn hundreds or thousands of placeholder objects that get reused. As an example, I could spawn 10,000 projectiles when the game starts that are inactive. Then when a projectile is fired, I simply take one of those from the pile, change the settings to match a fireball, and send it off. When the fireball hits a target or its lifetime ends, it gets reset to default values and placed back to the inactive pool. In the case of VerticalThird, our action spawner master is initially spawned in the world, and as the ability chain follows through, we add scene components to the master to execute follow-on abilities. Adding a scene component to an already in the world actor is drastically cheaper than spawning a new entity in the game world. In addition, the action spawners also handle your telegraphs, which can scale the telegraph based on the original abilities, instructions, or through designer set options. Sometimes you want the telegraph to be slightly bigger than the actual ability for a bit better gameplay feel or visual information for the player. The next category I want to go over is AI logic. Now, my work with VerticalThird has really made me to kind of reduce what type of combat abilities the vast majority of boss encounters or normal AI enemies will use. And so think of these as just certain scenarios where they can or can't use abilities. And in VerticalThird, our AI logic runs at about 4 times a second. So it takes about a second and a half for it to go through each one of these steps. But it's something that is constantly running and cycling through to basically understand what its next ability should be used. And so the first one that comes up is defensive abilities. And these very much are how they sound. It's basically an example would be a mage that has like a teleport ability. And if you want your enemy to only use the teleport when a player jumps on top of them, say with a charge or something, it's an ability that can only be used if their target is in a small radius around them, and it will never trigger an action to move towards them. And so a lot of times with AI, you have, if the enemy is out of range, they will obviously trigger to move towards them. But a defensive ability is specifically that in that it can only be used when a target is close to them, and that's it. If they're not close to them, it will basically move to the next category in the rotation. Another example would be a tank that wants to use maybe a block spell for melee attacks, but you're never going to want to use that if the melee targets are running away or just not in range. Which moves on to the next state, which is engage abilities. And engage abilities are exactly how they sound. If the target is trying to chase after a player, then that is the only time that they're allowed to use engage abilities. And so it saves it for basically if the enemy has a charge attack or a dash attack, they can only use it when the player is running away from them or they're chasing the player. Maybe they're out of range. And this is the type of ability you, of course, wouldn't want them to really use if they're just right next to the player. And so the limitation here is they have to be in the moving to target state as they chase after a player that will allow them to use this ability. The next up would be a buff ability. And this is exactly how it sounds. It's basically going to scan the area for different allies, and from there, randomly choose one to apply a buff to. And again, this is kind of the category of the what the action is kind of thinking about and what doing, but you could easily put in an area effect fire explosion in that place as well to basically, hey, my ally is over here. I'm going to randomly cast a big explosion in that area. But it's basically a category that is randomly casting a buff on a certain ally, or randomly casting an ability on a certain ally. Then after buff, we have the heal category of spells. Now, the heal category, again, it's just kind of how it's kind of scanning the combat situation. The heal category is going to scan allies in the area looking for something that's under 70% health or whatever threshold you decide to choose to do. And so that's basically, it could be a healer, obviously, kind of monster that's healing its allies when they get below 70% of health. But once again, you could do a crowd control ability. So, my friend got to 50% health. I'm going to cast a giant root around them to stop the damage, or maybe it's an area effect explosion that knocks everyone back, and these type of things. And so it's purely the factor of the logic has moved on to, I'm going to scan my allies for anyone that's low health and then use them as a target for an ability. So now we go on to, just like buff, we also have debuff. And so as you can expect, it's very similar. It's basically the complete opposite. Instead of looking for an ally to use a spell on, it's going to look for a random player on the threat list to use a spell on. The debuff category is randomly looking for a player on the threat list, targeting them, and casting any type of spell on them. And so this is kind of like one of those things that you could throw out some area effect damage randomly. Maybe it targets them and does a charge to them to like disrupt the fight. Any type of damage over time. Maybe it's targeting specific. You could further code it to target specific casters and maybe take them down their mana. But anything you can think of, it's basically a randomized attack against certain players on the threat meter. And the sixth and final one is the offense rotation. And so this is obviously the main attack rotation of your character. It's probably going to be some melee swipes or, casting fireballs, that type of thing. And it's important to note that any character can have any number of abilities throughout all of these, right? And each kind of category could have 10 abilities in it, or they could have no abilities in everything and just one offensive attack. And so it's just a way of really systemically reducing everything down to a specific number of categories. And each one of these, each abilities is still going to have its own cooldown. And so once an ability gets used, it can't be used again for X amount of seconds. And then within each category, you can still randomize them. Just like if the defense category gets triggered, you can randomize from 3 possible abilities from that pool of abilities. Or you could have them go switch one by one. It could be shield wall first, then it could be a teleport after that, and vice versa. And so there's a lot of things you can do with this, but it basically covers a lot of the different kind of functionalities that most AI you see in encounters. And so one thing I want to say is, if you think about a situation of a boss that has maybe something unique about it that doesn't fall into one of these kind of categories, please put it in the comments below and let me know what you think. Now, as I mentioned earlier, AI enemies also have the ability to have passives, just like a player would. And that can be on block, on crit, on hit, on parry, on dodge, these type of kind of passive actions. And it's kind of funny, it's kind of hard to name within your actual game a little bit, but there is the my attacks. And so my attack hit a target can trigger another action or ability. And then there's enemy action. And so the enemy action hitting me can also trigger abilities, that type of thing. And so even though it's a passive like dodge mechanic, there's 2 kind of variations of it. And so, like I mentioned, there is block, parry, dodge, hit, and crit, and 2 forms of each. Like if there's an enemy with a shield, every time I hit that target and they block it, for myself, I can proc something that only triggers off block, but then that enemy could also trigger something that is when they block an attack, something else happens. So I'll go something like thorns damage, you name it. And the next ones are resource percent passives. And this is basically your typical, your health drops below a certain point and something triggers as a result of it. And so a common one is obviously in boss encounters, and the boss basically, falls down to, 70% health or 66% health, changing their phase 1 to their phase 2 kind of transition. Or there's sometimes, you do more damage when you're low health type buffs and all these kind of factors. And so in VerticalThird, we kind of have like an agnostic resource system. So you have your health, you have your primary, secondary, and tertiary resource. And that way you can kind of name them whatever you want. Obviously, typically it's kind of mana and stamina, and then maybe like an ultimate power type resource, but it's up to you to kind of rename those. And so that's all of these passive kind of abilities and systems are all in addition to their typical, the previous logic, AI logic, and kind of mental thinking of how abilities work. And so that really comes down to the meat of how I've kind of reduced AI logic and AI creating abilities. Now you'll notice here that my ability system for VerticalThird is kind of agnostic for AI and then also players. So you never have to worry about basically creating a different system for creating abilities for AI compared to players. They're both the same. They just have different options that you can tweak within the settings. One of the workflows I'm trying to create with my game architecture is when you're designing your abilities, you're thinking one thing at a time. And so if you want an explosive fireball, you would create a projectile first for the fireball, and then you would create an AoE explosion as a second ability. And so when that fireball flies off and hits something, it triggers the next ability, which in this case is an explosion, right? And so I'm trying to get this workflow of think about single abilities, and then you basically combine all those together to create a bigger encounter to make interesting combat. Whenever you're playing a game yourself, you can always take a look at the abilities you find interesting or boss fights and think about every single thing that boss is doing and break it down into single actions. Is it a projectile? Is it an area effect? Is it a melee swing? Could it be a cone, a beam, a slime on the ground dealing pulse AoE damage? What could those be as a single entity? And then how can you kind of break apart ones that might look like they're a single thing, but break them apart into two separate things? And so that's just one idea of kind of reverse engineering how other games build their combat and their boss encounters. So it's a good idea, and I think it's a good practice to get into. And if you find that interesting, drop a comment below with what you broke down, or come to our VerticalThird Discord channel and we can talk about it there as well. The last thing I want to mention too is it can be helpful to have multiple perspectives in your game. And I know typically it's like you're building a first-person shooter, a third-person game, a side-scroller, but a lot of things that make new games interesting is being able to swap between the different perspectives. I'll highlight Mario Odyssey for this, as they're constantly switching between 3D and 2D, side-scrolling, those type of things. Even in Destiny, you have basically your normal first-person shooter combat, but then you throw up your ultimate and you go into third person. So there's a lot of different things that, even on that note, even Overwatch did some of those things as well. And so don't always lock yourself into just one perspective, and having these kind of different things at your tools to be a different or separate different game mechanic. I'm pretty sure plenty of MMOs have kind of thrown in little side quests or mini games that kind of utilize different perspectives there too. And so in VerticalThird, we have all the expected ones: first person, third person, side scroller, and there are a couple of different isometric and top down point of view. These are all kind of mixed together. So keep that in mind for the future as well. And moving on, as you might have seen from my a couple clips through VerticalThird, it's really good to have a complete layout of single, basically, mechanics in a test level. This is really important to make sure you can always go back and check whether or not something's working as intended. And so this is kind of my test level or my QA level. And it really lets me figure out that if something is going wrong with my with a bug or something, I always have a kind of single mechanic placed somewhere, how it's always supposed to work. And I know that if I always go to that thing and test it, it should always work in the correct manner. And so in programming, this is sort of like a manual unit test in a way. In the future VerticalThird and game architectures, I think we'll have, not only will we have these basically test levels with everything set up, but we'll also have automated testing also integrated to it as well, which means you can basically have the computer and the Unreal Engine basically push a button and it'll run through all of these things for you. And it's something that you do have to kind of build up yourself, and it will basically prove that everything works as intended, all at the click of just one button. And this wraps up our first general overview of game architecture. As you can tell, there's much more depth to each system that we can go through. So you'll have more videos like this in the series in the future. A common theme throughout this video is having very specific use cases for each component, even if that means it being somewhat small of an object or script. Thank you very much for watching the video. Remember to like and subscribe, as we're still a growing channel. And by all means, if you have any comments or suggestions, please put them below. Thank you very much, and I'll see you in the next one.